And we're back. So, to kick off this event, we are going to start with our friend in Hong Kong, Boris Kriuk. Kriuk, right?
Yeah.
Russian background. Boris is a globally recognized leader in machine learning, data science, and deep learning. He is the co founder and CEO of Sparkus Technologies Limited. And Sparkus Technologies Limited is an international research oriented startup that is developing AI solutions for logistics and supply chain management. Today, he's going to be sharing his findings from the research and benchmarking efforts around different attention mechanisms. What are attention mechanisms? That's a question for Boris to answer. So, with that, I'll leave him to it. And yeah, welcome, Boris.
Yeah. Thank you for the introduction and having an opportunity. I want to express my sincere gratitude to everyone who is involved into the organizational process to host this wonderful event. And today, I'm gonna share our latest research work on the attention mechanisms in computer vision, and our latest work called smooth attention, improving the image semantic segmentation. Yeah, and again, my name is Boris, and I'm uh, deeply involved into deep learning research, and you can always find me at the contact information provided below. Yeah, but before we will start talking about the concept of attention mechanisms and smooth attention, I think it's still important to have some concept definitions first. So let's start with the concept of the semantic segmentation for images. So what is it? The goal of semantic segmentation is to label each pixel of an image with the corresponding class that this pixel represents. So to simplify, we have one pixel that should correspond to one class that represents this pixel within the image. And in the next slide, I'm going to share the example of it. So we have the picture that represents bike riders, and we can clearly see that the black background is represented by a class as a background. The bicycle is segmented with green, and the person is segmented with pink color. And again, we have three classes. We can go even further. We can say that, well, there is a road in the background. There is, I don't know, the wall. But for that case, we need to understand that one pixel corresponds to one class level that is segmented. And the next definition is the attention mechanisms and their role in computer vision tasks. So the primary role of attention mechanisms in computer vision tasks is to help the model focus on the relevant parts of the image so that we can classify the object correctly. Yeah, we can again see the visualization below. For each image, we have the, let's say, heat map generated, where we see that certain areas of the image help the model achieve stronger results. And with that, we can move further. This is the visualization of the attention regions generated by the attention mechanisms. And here, where we have, let's say, two birds, we understand that in the ideal case, our model should represent the birds as two attention regions within the image. Still, there is a problem that in the real world scenario, oftentimes we'll get something like this, not the ideal case for the attention model generated. Yeah, and to understand why this happens, we need to consider the model architecture first. So to the left, I present a very simple model architecture that is used for the semantic segmentation tasks, that is represented by the encoder model and the decoder model in between with the attention mechanism. After the image is passed through the encoder model to the attention mechanism. At this step, we generate the attention matrix with corresponding weight for each pixel within the image. So here we can see that there is an area where we have non-zero pixel values in the matrix. It means that, well, clearly this is the region of the attention. But still there are some outlier pixels like here. And if we know, for instance, that there is only one bird that should be represented within the image, we understand that clearly there is something wrong with that. So all these inconsistencies within the attention matrix generated lead to higher computational expenses and inaccurate model predictions. When, again, we understand that there is, for instance, only one bird within the image, we see that within the attention heat map generated, that is usually pretty large because the image has the sizes of 256 by 256 pixel values. The famous mathematician John von Neumann can clearly label the problem that arises within this large spatial representation of the attention matrix. In 1954, John von Neumann introduced the Neumann hypothesis that can be summarized into one sentence. The larger the hypothesis space, the more difficult it is to find the hypothesis within this hypothesis space. So since our hypothesis space is pretty large, for any algorithm, it will be extremely complicated to either reject the hypothesis or to accept the hypothesis. And in Sparkus technologies, our goal is to work with the image semantic segmentation in such way that we will overcome the problem of spatial inconsistency. And I also need to mention that there is another challenge. Since the image is RGB, we have not two-dimensional metrics. We have three matrices that are two-dimensional. And that is why within our research team with three major authors, me, Fedor, and Karthik, we have proposed the mechanism called smooth attention with the primary goal to overcome this problem of spatial inconsistencies within the attention maps generated. So let's talk more about the concept of smooth attention. The first step is the projection of the input tensor into queries, keys, and values, just like in the famous transformer model architecture. But since we are working not with text but with images, we switch the labeled text tokenized into numbers to convolutions, and we apply the same principle to get queries, keys, and values from the convolutional representation. After that, again, just like in the attention all you need paper proposed, we compute the attention scores using the scaled dot product attention. We compute the softmax function from this formula. And the key difference comes at the third step, where we address the incoherence with the smoothness enforcement mechanism. And to do this, we introduce the multidimensional smoothness enforcement method using Chebyshev distance. First of all, in the multidimensional space, we identify the maximum distance between the corresponding inconsistent pixels within the attention matrix generated. And after that, if the distance is larger than the threshold set up by the scientist before the algorithm is run, we apply the smoothing mask. And in the end, just like in the LSTM or GRU unit function, we compute the corresponding output value for each pixel within the attention matrix. And this is the key difference that helps smooth attention overcome the problem of inconsistency. Let's talk more about the experiments. First of all, we need to highlight the landscape that we use for the experiments. we code a customized unit architecture that is oftentimes used for the semantic segmentation tasks. For the encoder, we choose the ResNet 18 model trained on ImageNet, followed by the smooth attention as the attention mechanism, and the decoder is represented by the series of transposed two-dimensional convolutions followed by the ReLU activation function. From the industry standard, the key difference is only the introduction of the smooth attention for this model. And yeah, to highlight the diversified data representation, which is extremely important for any AI research, we use multiple industry standard research data sets, such as fish segmentation, bird segmentation, fire segmentation, medical instrument segmentation, and even flood segmentation. Yeah, and of course, due to our format, I will not jump jump into the details of the experiment results, but still I need to highlight certain aspects of it. And for instance, we can see that with our research team, we go through each threshold value, and as the metrics, we use the intersection over union, test dice, test accuracy, test precision, test recall, and test event score. So this diversified metric representation also highlights potential outliers and helps us as researchers to identify the primary goal of each step that we make. So also another important moment, since we apply the smoothing for a threshold value, and we understand that the weight that corresponds to each pixel can be represented by the values from 0 to 1. Everything that is above 1 means no smoothing applied. And in our research, we use the 2.0 threshold to highlight the test results for the model that is not using smoothing in the attention mechanism. Yeah, and here, of course, we can see the improvements across multiple metrics for different thresholds, but still I understand that it is very important to visualize the result. That is why let's talk more about the visual aspect of the improvement. Here we can see the results for the flood semantic segmentation dataset. And to the left, there is the result of the attention metrics generated as a 2D heat map without smoothing, and to the right with effective smoothing applied. And yeah, visually it is pretty clear how the consistency within the attention metrics is improved. And the same data set, for the same data set, I also present a three-dimensional heat map for the results demonstration. And since we understand that the flood images, they are usually pretty consistent. The flood areas are very consistent. That is why when we have multiple inconsistencies generated within the attention map, the question should arise whether these inconsistencies are relevant. But once the effective smoothing is applied, we can see that clearly this is the region of the attention that can help the model focus on the relevant part of the image to segment the flood results more effectively. And also, just for the general understanding, I present the results for the fish segmentation. And also here I demonstrate the effect of the light smoothing applied and the strong smoothing applied at this stage of the attention mechanism. With the light smoothing, the trend is pretty obvious. We understand that the fish is here, but still we can see that there is not such a strict enforcement applied as, for instance, in these scenarios. Yeah, the trend is visible, but still here we can see the effect of the strong smoothing applied to the image to segment the fish within the pixel level distribution. And finally, I am happy to have the real world visualization again for the flood semantic segmentation data set. We have the images to the left with no smoothing and with the effective smoothing to the right as usual. And clearly we can see that the effective smoothing helps the model capture very complicated shapes such as two cars um, demonstrated together. Also, there is some pixel level inconsistency shown to the left with no smoothing. The shape of the bridge can be more accurately captured with the effective smoothing rather than without smoothing. And also, this road, which is pretty light, disturbs the model from the accurate segmentation result. And in the case of the effective smoothing applied, we can achieve a more consistent result. Yeah, and to the very right of each image, we can see the true mask. That is the accurate level of segmentation. Yeah, but still there is a lot of work to do for the algorithm because, since we have mentioned it before, I will repeat it. The spatial inconsistency within the attention map is a very complicated problem that, with our limited computational resources, is not that easy to overcome at all. Yeah, and to summarize, in this paper, we present a new attention mechanism for the computer vision tasks. We help the model to improve the spatial understanding and consistency, and also we help the model learn to segment complex shapes more accurately. More than that, with our introduction of smooth attention and the opportunity to change the threshold value, we provide the rigorous regulatory framework for the smoothness level representation. And yeah, thank you very much for the attention. If there are any questions from the audience, I'll be happy to address them.
Thank you, Boris. So I really enjoyed you opening up the presentation with the idea that the bigger the hypothesis, the harder it is to define and grasp, versus if you have a smaller hypothesis, it's easier to define experiments and be more precise in targeting what it is that you're doing. So we have a question from Armin, and I think you answered that in that slide with the number matrix where you had varying values. Do you mind flipping back to that slide with the matrix of values showing how you're sorting out through the noise? This one.
Yeah,
So, yeah, the heat map and that attention matrix. Can you describe what smooth attention is doing?
yeah, with pleasure. So the primary role of the smooth attention from the conceptual perspective is to smoothen the attention metrics and the pixel value representation. Here, when we identify that these pixels are definitely outliers and we should not classify them as the regions for the model to focus on to get better results. Our job is to uh, eliminate these pixels, meaning that the values for this pixel should be also zero as the surrounding. So coming back, I will not focus on the complex formula. Coming back to, let's say, this visualization, you can clearly see that the regions of the spatial inconsistency are eliminated and we achieve a much smoother and a much consistent attention representation of the attention metrics.
Armin has a follow up comment. Also, Aditya is saying thumbs up. Manas is saying clapping hands. Thank you. Armin does have a follow up to that explanation. He says it seems to me as a low pass filtering on ROI or ROL. Am I sensing this correctly? That's nomenclature that's outside of my pay grade. What do you say to that?
Can you please display the comments again? Yeah,
Mm-hmm.
it seems to me that it's filtering on ROI.
My very basic understanding is that there are things that matter and things that don't matter when you're looking at a complex shape. And if you want to remain efficient in your computations of identifying entities and the relationship between entities, you want to remove the focus away from the things that aren't easy to identify and focus on the things that you can. Is that what you're
Uh,
trying to do? Remove the noise from what you're looking at just so that you can make it more efficient for a computerized system to tag and track and interact with some entity in the video feed or image feed?
um, I think I will expand on this idea when we work with the
Oh,
computer.
region of interest. Region of interest. Oh, there you go. Thank you
Okay.
for
Yeah,
elaborating.
yeah. Because I was a little bit perplexed. Like ROI is oftentimes referred to as return on investment, right? Especially as the founders, we understand that. Yeah. To expand on this idea, generally speaking, when we work with the computer vision tasks and there are multiple images that we need to work with, of course, they all may have similar distribution, especially when the classes that we work with are similar. If we work with cat images, and the distribution will be similar, but still we will never get the exact same distribution for different images if it's not the same image at all, right? And when the attention mechanism receives the pixel level distribution, oftentimes since the variety of data is huge, attention mechanism can be confused by that. And since nothing in this world is perfect, of course, there will be some inconsistencies within the attention matrix generated. And yes, answering that question, our goal here is to smooth the result of the attention matrix that is responsible for the region of interest within the image.
Okay, we're getting some emojis here. Someone's giving you a high five. Someone's giving you more clapping hands. Armin's giving you, recognition for that explanation. Gabriel's saying, "Great presentation. Congratulations." And we have one more question. Is this segmentation the way through which some mobile phones are able to remove unwanted objects from the background?
Yes, yes, it is. For the mobile phones, the architecture should be slightly corrected because when we work with mobile devices, our primary goal is to use less computational expenses and also to diminish the model size so that it will work efficiently on the mobile application platforms. So usually when the model is trained like this for the segmentation task, after that it is pass through the distillation approach. And the goal of the distillation approach is to diminish the model size without heavily affecting its accuracy. And after that, it can be easily used in the mobile devices.
I think, like you were talking about ROI being another acronym for return on investment. There are multiple ways to look at the advantages of smooth attention. And one of them is being able to identify a more complex shape more effectively, functionally, but also that saving of computational power, because each additional computational power is adding to the server cost, adding to the consumption of energy. So that efficiency translates over to every user of that computerized system, right?
Yep, exactly. Um, Especially working in the current age of the cloud advancements when we train the model in cloud, we host the model in cloud. Of course, all the inefficiencies lead to higher computational expenses. And for any company that currently works within data, big data, or generally speaking, AI field, it's extremely important to develop models that are not only accurate but also computationally effective.
Armin is saying, I think I heard a paper published or being published. If so, please share a URL. That's something
Yeah,
we can do after the event. And
yeah.
Lois is saying, very explanatory presentation. I learned a lot. Um, so, yeah.
Thank you. Um, Yeah, I think that I can leave the link to the paper in chat if that's possible. For instance,
Yeah, you
right
could do
now.
that. Yeah, you could do that now.
Okay. Is it visible now?
I'll share it. That's in the
Oh,
private
okay.
chat. That's okay.
Okay.
So here's the paper. You can access it there. I'll put it here in the video screen so anybody can just type out the URL too. But yeah, let me ask you this: what comes next? Now that you've benchmarked and seen the advantages of this mechanism, how are you seeking to implement this or validate a use case so that you can get wider adoption?
Uh, the adoption usually, especially when with some fundamental research works, happen through the uh, global uh, recognition from the publishers. And our primary goal currently is to publish this paper at a very high ranked journal so that we can get more traction and let the public be familiar with our ideas and our concepts. From the industry perspective, there is also a lot of work to do. Again, in the way that the model is developed nowadays, it is not efficiently to use it in the mobile devices or even to deploy it within the web platforms. So also we need to have certain steps within our research team. It usually takes for us around 2 to 3 months to prepare the model for the commercial use as well. And through our partnerships, academic partnerships, and industry related partnerships, we will, as usually, promote the commercial model as well.
Excellent. And I imagine commercially you're going to adopt it to logistics and supply chain management as that is your area of focus, right?
Yes, that's absolutely right. Also, due to the very fundamental nature of this research, of course, it can be um, applicable to other industries as well. And
Yeah, anything that's detecting entities.
yes, and we will discuss first of all within the commercial department how we can approach the industry with this type of the solution, and after that, of course, we will do some minor technical changes, deploy the model, and it will be ready for the uh, publicly available usage. Let's say.
We have one last question here, and then I will let you go because I know you have another call and you're in Hong Kong time, so it's end of day for you. Thank you for the explanation. I'm not familiar with all this technical stuff. Hey, me neither. I'm learning this as well. He said I could just relate this with some basic info. So distinguishing objects in an image, we are able to edit them better or remove them or do something like a deep fake. Please correct me if I'm wrong.
Um, yes, it can be done. Still, for the uh, deep fake, we need to address the slightly different sub area of computer vision, which is called adversarial attacks. We need to uh, um, check the pixel level distribution of the image and using the algorithms identify the potential areas of the uh, misleading information presented. But as the way to get the uh, attention regions within the image, and after that apply the algorithms that help identify the potential adversarial attack regions, it is still possible to apply smooth attention.
Boris, it's been a lovely time having you here. This presentation will be made available in the next 15 to 30 minutes. People will be able to rewatch it on demand. So with that, I'll let you go, man. I know you're busy, and thanks a million for
Thank you.
presenting.
Thank you very much. Thank you. It's a pleasure.
We'll see you guys briefly in another 10 minutes. So stay tuned.